Dependency injection is a programming technique that makes a class independent of its dependencies. In our app, we are almost done with our user methods and our app architecture. We got small pieces of code in our app which is separated according to the principles of clean architecture. Now before going forward and utilize them in the UI, we must notice one thing. We have many classes and are decoupled from its dependencies and are accepting these dependencies through the constructor, but we somehow have to pass in them. Almost every class has some dependencies. If you look at in the repository, in the data layer, the repository implementation has the dependency of Firebase remote data source. This Firebase repository implementation depends upon the Firebase remote data source. Same like this, inside the data sources we have the remote data source implementation. The remote data source implementation depends upon these two externals, Firebase Firestore and Firebase Auth. And again, as I said, dependency injection is the programming technique that makes a class independent of its dependencies. So how we can achieve this kind of independency? There are multiple ways of achieving this kind of independencies like inherited widget and also the provider. But in our case, we will use the getit package. If you remember in the second video, we have added the package of getit, which is a simple service locator for Flutter. It can be used instead of inherited widget and the provider. Now look at this architecture. So far, we have created many classes from our presentation logic holders, Cubits, to the ending remote data source. We are going to register all of these classes in our injection container so that we will be free to use these classes anywhere in our UI. So just like this, we are making our classes independent of its dependencies. Now first thing you have to do is just to move to your Android Studio, and where this main onGenerateRoute and const is located, just you have to create a Dart file and name it to injection container. After this, hit enter so your file will be created. Inside this, first we have to take the instance of getit, and be sure to check out the written tutorial from where you can get all of this code and also learn all these things by going at your own pace. So to take the instance, we have to store it inside a variable final sl equal to getit dot instance. So we got the instance of getit. Now down here we are going to have a method of future. Void, it means nothing, a simple callback, its name will be init and will be async open body. Inside this method, we will register all of our classes using this SL, which is the shorthand of service locator, and this init method will be initialized in the main.dart as we have initialized Firebase here. So again move to the injection container, and this SL provide us many methods. First we have to make some comments to keep our code organized and clean. So I will comment first we are gonna have qubits. Next we are gonna have the use cases, and third we are gonna have the repository, and lastly we are gonna have the externals. So first we are going to register the qubits, then the use cases, then the repository, and lastly the externals. So these comments are useful just to keep our code organized and clean. Now this SL service locator provide us some methods like sl.factory register and also the lazy singleton and singleton and many more. I will explain all the register methods that we are going to use. So first do sl.registerFactory, and this returns a simple null for now, but semicolon here, and as there is a comment qubits, here we are going to register our qubits. So I will put the name of my qubit class auth qubit. So you can see the error is gone from this register factory. First let's replace this sign out use case on sl.call. I will explain what this sl.call means and also this register factory, but first do it for all of them, then we will go over both of them. Paste it on here and also in here, and put comma here and also here, and press Ctrl Alt Shift L, this will appear, hit enter, so this will format your code. Now we are talking about this register factory first. Then we will go for this sl.call. That's why I did this sl.call here. This register factory means each time when we request on this factory, this will give us the new instance, and this is a good way of registering view models or our qubits, because that runs the same logic on start, or that has to be new when the view is opened. Now we will be able to request on this Cubit class of anywhere from our UI by putting its type. What it means by putting its type, it will become clear when we do it practically. So that was our register factory, that it gives us new instance each time when is requested. And now let's come to this sl.call. What this sl.call means? This sl.call is because the getIt is also a callable class. You can see it here. So by doing this, the getIt will start looking for the register types, much like we are registering this auth qubit. So like this, we are going to have the sl.register factory, and this will search for sign out use case. It accepts the repository. Again sl.call. First forget this repository, I will explain this later. First focus on this common sl.call which we have in the qubit. So when I did this sl.call, this getIt will start looking for the register types, and as soon as this type is registered here, so this getIt will resolve and will grab it and instantiate it, and then simply pass it in here. And the same will goes for the remaining two, is sign in use case and get current UID use case. So we are going to register the use cases also just like this, but first remove this from here because we will do it using another method of service locator. So remove it, and I will explain these other methods of this service locator also. So again, this register factory create new instance each time when requested, and that sl.call in front of these use cases, the getIt will look for the register types. When it found the register types, that will grab it, instantiate it, and simply pass it in here. That's it for these sl.call in front of these use cases of this auth qubit, which are the dependencies of this auth qubit. And after this, we have some more methods on which we are going to register our use cases. So we will do sl.register. We have the singleton and the lazy singleton and many more, but we are not going to touch all of them in this video. We will touch only the lazy singleton and this factory. With this, we will also explain this register singleton. So we are going to register these use cases on the lazy singleton. So what's the difference between them? The regular singleton, not this lazy, but the regular singleton, as we have seen in a while, always register immediately after the app starts, and these lazy singletons only register when it's requested as a dependencies for other class. So we will put the name of our use case in here, sign out use case, and in the repository sl. And forget this repository sl.call for now. Now you might be thinking why I register these qubits as a factory and my use case as register lazy singleton. You know about this register factory. This gives us new instance each time when requested. And however, this lazy singleton or our regular singleton, this will give us the new instance only for the first time, and then subsequent call to them throughout the lifetime of the app. It will give us the same instance and will not instantiate a new instance since this is a singleton. So on app starts or we request it on this register lazy singleton, this will give us new instance only one time, and then this getIt will cache it for the future use, and then subsequent call to this register singleton or lazy singleton will give us that old instance that getIt cached previously. Now there might be still question in your mind that I didn't say why we did this register factory for Cubit and why we did this register lazy singleton for the use cases. You will say I only explain the register factory and the work of these two methods, register lazy singleton and a regular singleton. I register my Cubit as register factory is because your app do have multiple pages, like our Instagram app have multiple pages. When we navigate between these pages, we probably want to do some cleanup, like closing the streams, and when we navigate back to the same page from which we have navigated to the next page, we want the new instance of our Cubit to rebuild our UI. So in case if we use the singleton and navigate between the pages, so first time register lazy singleton will create the instance for the first time, and when we navigate to the next page, so the Git will cache it. When we again back to the same page, so the Git will give us the same instance in which we have closed the streams. So this might cause the problems when we register our qubits or our view models as a singletons. So presentation logic holders should not be registered as singletons because each times we want their new instance, so we must register them as register factory to give us new instance each time. And then we register our use cases as lazy singletons is because we don't want the new instance each time, and these use cases do not hold any kind of state or any sort of closing of streams and anything like this. So it doesn't make any sense to factory register these use cases and get the new instance if we can use the already created one. So that's why we use the register factory for our Cubit and the lazy singleton for our use cases. So now copy this and paste it 2 times because we do have 2 qubits. One is of credential qubit and this accept some other dependencies, that is sign up use case. We will do it sl.call and sign in use case sl.call, and with this Git will search for the register types which we are going to register with the register lazy singleton in a while. First let's cover these qubits. So this auth qubit will be now user qubit, and remove these dependencies from here. This accept sl.call which is for update user use case, and after this get users use case sl.call. So we are done with our qubits. Now let's go for the use cases. The use cases will be almost the same and I will explain this repository. First let's replicate them and count them, as we have only 9 use cases. So these are 10 use cases, so remove 1 from here, and now let's change only the name of them. Sign out use case, and the next is sign in and get current UID. So we will do is sign in use case, and the next will be get current UID use case, and the others are sign up use case and sign in use case. So we will do sign up use case and sign in use case, and the next are update user use case and also the get users use case, and the remaining 2 are create user use case, and the last one is get single user use case. From this get single user use case, an idea sparked in my mind that we missed something in the previous video. So it's okay for now, we will cover it at the end of this video. First, let's continue it. So now what about this repository and sl.call? This will be the same as I said about these SL calls in case of these use cases. So as we did this SL call, and after this Git start looking for the register types, so they will find the relevant register types here and then grab them, instantiate them and pass them for all of them. Just like this, the same will be for the repository. So now we did sl.call in front of the repository, so it will search for the repository which we have not registered for now. So to register the repository, we have to do again register lazy singleton, and if you remember, we have the repository in the domain layer, which is an abstract class. So abstract classes cannot be instantiated. So we have to instantiate their implementation. It will be the Firebase repository implementation, and this accepts the remote data source. So we will again do SL call. Again, this will search for the remote data source which we are going to create in a while or register in a while. So we register our repository just like this. With this, we have to do one more thing to pass the type in here. This will be of Firebase repository, which is the abstract class. Like whenever we want to register the implementation of any abstract class, we have to specify the class abstract class as the type parameter. So just like this will be registered, and the same will be for the remote data source. We will comment out the remote data source, and just like this, copy it from here, paste it right here, and this Firebase repository implementation will be remove this from here, and there will be Firebase remote data source, not the remote data source but its implementation. Just because if you look at the remote data source, that's also an abstract class and its implementation is in here, which depends upon some two externals, and we will call sl.call for them for now. sl call and sl call. So there is an error. Why is that? Just because we have to pass its abstract class, which is Firebase remote data source, so the error will be gone. And we also did the sl.call for the externals just like this. Now how we can register these externals? These will be a bit different from all of them. So first we have to take the instance of them, like final Firebase Firestore equal to Firebase Firestore.instance, and also final Firebase auth equal to Firebase auth.instance. So I got the instance of them. Now we will register them as lazy singletons. sl.register lazy singletons, and we will simply pass the Firebase Firestore, put semicolon here to complete it. Now press Ctrl D to replicate it and pass the Firebase auth in the second one. So we are also done with our externals. Now let's take a quick recap of all of them, that what we have done in here. So we have this register factory method which give us the new instance each time when requested. So this will give us the new instance of this auth qubit whenever it's requested, and this sl.call will search for the register types which we have registered in here, and these are lazy singletons. This will give us only the new instance only one time, and then the getit will cache that instance, and the subsequent call to these instances will give us that same old instance, and that's okay. We only want that instance because for use cases we do not want the new instance each time. As I said previously, it does not hold any states and like closing any streams and anything like this. So we keep registering our use cases as register lazy singletons. So whenever these are requested as a dependencies for other classes, first time they will provide the new instance and then getit will cache it, and for throughout the lifetime of the app, this will provide the old instance that is cached by the getit. So that was it for these use cases, and now the repositories. Now we know that we cannot instantiate the abstract classes. So we register their implementation and pass the parameter type in here as the name of the abstract class. So just like this we can register abstract classes with their implementation, and the same is for remote data source, and the externals is a bit different. First you have to take the instance of them and then simply register them, and now we have all of these classes just like this. So we are free to use all of them in our UI by passing their type. How this will be possible? Let's go to the pages and let's say home page. Now let's say in here I want the instance of my get current UID use case. First, for now, let's make it stateful widget, and in here I want to get current UID. So what I will do, I should pass the complete Firebase remote data source implementation and then access it from here. No, that's not the good way. That's why we did the dependency injection and make our classes independent of its dependencies. So now we are free to use just like this. Let's say I want the current ID of the use case, so I will do di.sl and its type get current UID use case, and just like this is said, the name of the constructor must match the name of enclosing class. So we have to do import injection container as di, and let's cut it, put it inside the init state, and then import this get current UID use case dot call and dot then open body. This value will give us the current UID of the use case, but for now we don't have it, so I will show you in the next video when we start calling the methods in our UI, and I will show you how we can get this current UID in our home page or anywhere in the UI. So now let's remove it from here, or let's hold Ctrl and also hold the Z to undo everything. So that's it. Now close this and go to the injection container. We are done with all these dependencies, and there will come some more classes like our post Cubit, comment Cubit, reply Cubit, and many other, and also their use cases like get comments, get post, get replies, or create post, create reply, and create comment. Just like this, all of the use cases, and these repositories will remain the same, and there will come some more externals like Firebase storage. We will cover it in the upcoming videos. And now the last remaining thing is just to move to your main.dart, and as we have initialized the Firebase in here, you have to await di.init. Now what is that di? As I did in the home page, we have to import the injection container as di, and from that di we have to access that init method which we have inside the injection container, this init method. And inside this init method we have register all of the classes and the use case classes, abstractions and their implementations and externals. And now I said we forgot something in the previous video, so that is inside the user we forget to create the get single user Cubit. For that getting single user we are gonna have the separate Cubit, so we will create a directory. Its name will be get single user, and then there will be a Cubit class. Its name will be get single user. Check this use equatable and OK. Open it, and as you are familiar with these Cubits I explained in the previous videos, we want some stats like loading, loaded, or failure. So I copied this initial and pasted 3 times. So now I will change this initial to first loading, the second one will be loaded, and the third last one will be failure. Now as we have the user Cubit or user stat, we are getting the list of our users, like all the users, getting all the users. In this get single user stat we will do final user entity, only single user, not the list of the user entity. So again we will pass it in the constructor and make it name, and also make it required, copy it and paste it here. Now go to the Cubit, and here we want the same method as we have in here, so we will copy this get user from here and paste it in here. Only change its name to get single user, and not forget to pass the final get single user use case, get single user use case, and also pass it in the constructor required this dot get single user. Now change the user loading to the get single user loading state, and also the stream response will be from the get single user, and this not take any user entity. But if you remember in the repository, the get single user accept the UID, and also in the use cases get single user it accept the single string UID, not the whole entity. So we will remove this user entity from here. This will be simple string UID and pass this UID in here, so the error will be gone. And as its return type is stream list of user entity, so here we are listening to the stream, and this will give us the list of user entity, and from this list of user entity we will get the first user entity, which means only single user. So we will change this user loaded to get single user loaded, and also change the users to the only users, and also make sure to import this .io for the socket exception, and change this user failure to get single user failure, and copy it, paste it right here. So we are done with our get single user qubit. Now we have to inject it in the injection container. Also go to the injection container, go a bit up here, copy this user qubit and paste it down here. Only change its name to get single user qubit, and it accept the get single user use case. We will do sl.call, and get it will search for this get single user use case register type, and we have this in here, and this will grab it, instantiate it, pass it in here, so we are good to go. That was the dependency injection of all the classes, and is very important step in all the bigger applications. And be sure to check out the written tutorial from where you can get all of this code and also learn all these things by going at your own pace. And that was it for this video. In the next video we will go for calling the methods finally in the pages. So in order to not miss that video, be sure to subscribe and hit the bell icon to make sure you get notified whenever the next video is uploaded. And also follow eTechViral on Instagram to polish your coding skills on daily basis. So for now, goodbye, and I will see you in the next video.